For example 40, we're looking at finding the range given a function and given a restricted domain. So we're fine with this function idea, but now that we have a restricted domain, it changes things up, at least in our minds, because we haven't experienced this before. To start off, let's just input these values in for x and we'll see what happens. So for f of -2, we'll have 1 over 2 inside of -2 plus 5. Sub it into a calculator however you'd like, and your solution will be 1. If we put f of 0, we get 1 over 2 outside of 0 plus 5, and our answer then is 1 over 5. Now, even though we can graph this, I'll leave it up to you to see how that works using Desmos or by hand, but you'll find that given the range, -2, which is less than or equal to x, which is less than or equal to 0, you will find that the domain given is 1/5, which is less than or equal to y, which is less than or equal to 1, which we get straight from these inputs. Graph it and see how it works. See if you get the same idea. We'll try it again for example 41. Example 41 takes a similar question. Find the domain for y is equal to 3 on x, for 1 which is less than y or equal to y, which is less than or equal to 3. Well, let's substitute in and we'll see what we get. When y is equal to 1, 1 is equal to 3 on x. Multiplying x by both sides, we get x is equal to 3. And when y is 3, 3 is equal to 3 on x. So 3x is equal to 3. Dividing both sides by 3, x is equal to 1. So, given that the range is, given that the domain is 1, which is less than or equal to y, which is less than or equal to 3, so too is the range of 1, which is less than or equal to x, which is less than or equal to 3. Now, this is different for us because previously we were looking at the domain and range, including all real x and all real y, excluding the asymptotes. As we are looking in areas on a curve that do not include asymptotes, and we are required to graph to identify that, we can just find the domain and range for the given area, not the entire curve.